with division today. For some reason, I had a mental breakdown this morning in what was due, because I started grading papers at 4 a.m. and I graded right on through, except for 10 minutes it took me to get here. I graded until 7 o'clock this morning when we started the lecture. And I thought, since we did the counting unit yesterday, I didn't have any tests to grade. And somebody asked in the last hour, "Where's the review test you graded?" And my answer, I screwed up. So I will return that and this one today, tomorrow, get them caught up. My apologies to you. I didn't even know I'd screwed up until the question was asked. I have been grading algebra papers, stat labs, and having all sorts of fun. Now, division. This is intriguing to me because as a child, it was punishment for misbehaving. Long division. I went to a very small school. It was a parochial school, so it wasn't a public school. And so you could be kept after school very easily and nobody cared. And your parents usually wanted to know why you were kept after school, and they then caused you more grief when you got home. So if you were in school and misbehaving, one-room school, all the grades, one room, and if you misbehaved, you got kept after school, and the punishment was we are going to do long division for an hour. Didn't make you like mathematics very much. And so one of the questions that was asked in the last hour, and I thought it was an appropriate question related to this punishment that was meted out for being too squirrely in a classroom, why did you end up mathematics? And one of the people asked, what causes some people to get into mathematics? Like there's something wrong with that. Okay? What causes that illness? And part of that answer is if you happen to be good at numbers. And I don't know how that starts. I just remember from childhood of being rather comfortable with numbers. Now I know why my two sisters didn't go into mathematics. That was pretty easy. Why do you think they didn't? The answer, they weren't good. Maybe they thought that, but they actually are pretty good with it. What was their excuse?
Boring.
Their brother did it. If you're in a family and one of the family does very well in something, usually the sister or brother won't go into that. Because they are what if they do? They're competing. Teachers thought because I was good in math, my sisters would be good in math, and they rebelled. So one of my sisters was more in music than anything else, and she ended up in nursing, and guess what she had to study? Math. The other sister got interested in business, and guess what? She had to take mathematics, but both of them today, all these years later, say, I don't do math. My brother does. Interesting, looking at kids, Sarah and I have 5 of them between us. There isn't a single one of them in mathematics. They all chose other things because their parents did math. So they've chosen business, German literature, Spanish literature, business, and psychology. And they've all avoided doing mathematics. And one of them's in music. So, go figure. So the division we're going to do may or may not be your cup of tea. Now, I'm going to show you the typical division problem that I think all of us feel pretty comfortable in doing. And then I want to show you what was taught to me by a young lady in one of my classes who was from the Azores. And she saw what I was doing, and she said, I didn't learn it that way. And I said, well, will you show me the way you learned it? And she did. And it's the way the rest of the world does division. The way we do division, very few people do. Now, it's becoming more the case because other countries are buying books published in the United States. And so they tend to use the methods we're using in the United States. But before that, the rest of the world did not do division like I'm going to show you. Now, we did a problem yesterday that disappointed me because none of you barbecued. Well, one of you barbecued, but most of you didn't go to a picnic. You didn't make homemade ice cream. You didn't get a big block of ice. You didn't follow tradition. Okay? Disappointing. Here was the problem I asked you. And what was I trying to answer in this question? 12 times 144. Do you remember the answer?
1, 7.
Yeah, it started with 1, 7. Anybody fill out the last two?
48.
You got it. I heard a 1, 7 and a 2, 8. That's it. The 1728 is the number of cubic inches in 1 cubic foot. So if you have a block of ice again, 12 inches by 12 inches by 12 inches, you can get 1,728 ice cubes out of it. 1 inch by 1 inch by 1 inch. It's a nice number to remember. Sort of trivia, mathematical trivia. Now, will you tell me what this answer must be? Agreed? Do you hear that answer? The answer given to me was 1, 4, 4. Every multiplication gives you two division problems. So 12 into this will give me the 144. If I divide this by 144, what will I get? 144 into that number will give me a 12. So every multiplication, two divisions. So we know what the answer is supposed to do, or what it should be. Now what I want to do is carry through this first in the method I think most of you learned. Now if you didn't learn it this way, I'd be curious. So let's try it. 12 goes into 17 once, right? You can't put it into 1, so you go into the 17. You multiply this times the 12. You write the 12 down, you subtract, you get your 5. Agreed? And then what was usually done? Bring down the 2. And then you say 12 into 52. Then we know what the answer is supposed to be, so there's no guessing here. So I'll write down the 4. Because 4 times 12 is 48. Then I'll subtract, and then what do I do again? Bring down the next digit. I don't know if you draw the arrows. Sometimes you can do it without the arrows. 12 into 48 again goes 4. You get 48 here, and you say you're done because 0 is left. Did anybody learn their division different than that? Is that the way everybody did? Pardon?
My mom does it different.
Okay, but as the way you were taught in schools, pretty much this? Everybody? Agreed? Okay. I'm going to show you what I was shown and found out that the rest of the world did it this way. First, you need to realize that this division problem, and I'm going to use this space over here for a moment, Debbie, I could have written this way. In fact, if you were doing this in the calculator, you'd have to write it that way, because you have to put this in first, then the divide symbol, then the 12. Notice how it's just reversed from the way we do this. I think that's confusing. Here's another way that same problem can be written, and most of the time, I suspect you don't think of a division as a fraction. But that's also the same problem. Okay? In fact, if I line out the 12 and put a 1, and line out this and put a 144, you call it reducing the fraction. But that's a division problem. Now, as I promised, a different way. So we'll just pan over, and I'll back up with you just to there. Now, notice I'm going to write the problem in just the reverse order. So instead of putting the 12 on the left side, I do it like you put it in a calculator. Now, here's what the rest of the world tends to do. You say 12 into 17, but you put your 1 here so that you can multiply 1 times 12. And you don't write the 12 here. You just do it in your head and say 12 from 17 is 5. And then you bring down the next two digits. So you're doing a lot in your head. Now 12 goes into 52 4 times. So I put my 4 where I have the chalk. I multiply. Notice how nice it is because 4 is right below the 12. That's 48. 48 I subtract from 52, but I do it in my head and get a 48. The 12 goes into here 4 again, and I get 48. I subtract from the 48 and get 0, and I'm done. Is that the way your mom did it? Okay. Now, this is the way most of the world does it. It's harder, right? Because you don't get to write down the 12 and the 48. You have to do it in your head. So if you learn this way, you are doing more work. I think it's great. Okay, because you're thinking. Now, I'm going to create now a third method, and it is called this. Now, we're going to need to do short division for some of the problems we are going to do tomorrow. But let me show you the process. It's sort of like this, but a little interesting twist. Now, if I do enough of these, you'll remember that 12 times 144 is 1728. Hopefully you'll remember that. Okay, this is short division version 1. Suggesting there's what? Version 2, the second movie. Okay, more exciting than the first. 12 into 17 goes 1, right? So you take the 1 times the 12, you put the 12 here, and you say, well, what's different about that? You take 12 from 7, and you get what? 5. You put the 5 up here, not down here. So your remainder goes up. So I have 52. 12 into 52? 4 times, right? 4 times 12? 48. What do I do with the 4? Bring it up. I don't bring anything down, I bring everything up. 12 into 48 goes 4, 48, and I get 0, and I'm done. Now, I'm sorry that I'm mixing my 4s. As an engineering student, I had to do 4s like this. As a math student, I did 4s like this, and I forever am mixing them up for students. Okay? I don't want to do that. That's version 1. Let's do the streamlined version. This is even better. This is good. Okay, here we go. 12 into 17 still goes 1. Boring, right? But now, you don't put the 12 here. You do the 12 in your head, and you subtract 12 from 17 and get 5. That's all you show. And 12 into 52 goes 4. That gives me the 48. I subtract the 48 from 52 and get a 4. That's all you show. Then I get the 4 up here. I get 0 for remainder, and I'm done. This is short division version 2. That's what you're going to have to do tomorrow. Okay, let's practice it. I need some numbers. So we'll start over here. And I'm just going to go around here, and we'll stop at Lewis. And I want you to give me a digit between 1 and 9. Your choice is starting. 8. Okay. 7. Good. If you gave me a 6, I was going to crawl on your back. Okay, 5. 9. 4. 3. 1. I'm going to finish it with a 5. My choice. And I argue that I can divide by 5. What's my argument? Okay, very good. I can divide by 5 if the last digit is a 5 or a 0. Very good. So again, my rule for division. I can divide by 5, no remainder, as long as the last digit is a 5 or a 0. What's my rule for dividing by 2? No remainder. 2 or 0, that'll work. You can do better. 1 won't work. 4 will work. Give me a better rule. Last digit, even. Well, my last digit here was what? A 5, so 2 won't go into this. Okay, let's try 3s. What's my rule for division by 3? No remainder. What do I do? I heard somebody start it. Anybody? Again? Okay, that's not bad. That would work sort of like for 6, but and 12, but it's not going to work for 3. We're going to add all the digits. If our sum of all the digits in the number can be divided by 3, the number can be divided by 3. So let's check. And I don't know if this will work. Here goes. 8 and 7. 15, yes? 8 plus 7 is 15. Add 5. 20. Add 9. 29. 33. 36. 37. 42. Now add the 4 and 2. 6. Will 3 go into 6? Yes, so 3 will go into this number. I was lucky. Now, we're going to divide by 5, and then we'll do it again dividing by 3, just to make sure you agree that it worked. Are we ready? Short division. You got to think. Okay, 5 into 8 goes 1. What's left over? Leftovers. You know, they don't go in the refrigerator necessarily. Here's a leftover that you have in a division. So 5 into 37. 7. Leftovers. 2. 5 into 25. Leftovers. None. 5 into 9. Leftovers. 4. 5 into 44. 8. And leftovers. 4 again. Didn't say that right. I didn't write the numbers. 8 and the 4. Sorry about that. Now, 5 into 43. 8 times. Leftovers. 3. 5 into 31. 6 times, agreed? Leftover. 1. 5 into 15. The 3. Now, if you wanted to check this, what would you have to do? No. That was not an appropriate answer. The answer that you may not have heard was, use a calculator. You would multiply 5 times all this garbage and hope you get this. We'll just trust that we did it right, because I had a lot of people watching what I did. If I'd screwed it up, you'd have told me. I know that. Okay, we're going to divide by 3 this time. Okay, so I put my 3 out here. And my 8, and my 7, and my 5, and my 9, and my 4, and my 3, and my 1, and my 5. Now notice there's no room to do any borrow or subtracting. I just have to do it all in my head. You're forced because of space. Are we ready? 3 into 8. 2. Remainder? What's left over? 2. Agreed? Oh, I like this. 3 into 27? 9. 9 times 3, 27. Remainder? 0. Now, 3 into 5. Remainder. We had a 2 left over. 3 into 29 is a 9 with 2 left over. 3 into 24. 7 or 8? 8. Leftovers? Nada. So 3 into 3? 1. Leftovers? Nada. 3 into 1? 0. Leftover? 1. 3 into 15? Now, wasn't that fun? Jeez, insincere. You are not believable in the sense, oh yeah, it was awesome, sure. Just like hitting my thumb with a hammer. We're going to do a lot of short divisions. And they're sort of fun if you'll let yourself enjoy it. Now, if not, I guess if you've decided you're just not going to enjoy any division, then I can understand that. And in all fairness, if I have a rotten division, I will go to the store and buy a calculator before I would tend to do it longhand. But for what we're going to do tomorrow, this is going to be important. We're going to stack divisions. Let me give you an example. I'm going to start with 60. And I want to write it as a product of something else. And here's the restriction. Everything I multiply has to be a prime. Now, primes are numbers that you can't break apart any other way. So let me just list the primes. 2 and 3 and a 5 and a 7 and 11, and they just keep going. These are primes. Now, 9 I can write as what? 3 times 3, 1 times 9, 2 ways. But the 11 can only be written as a product in one way, 1 times 11. So here's what I do. This is called stacked division. So I have this 60 here. And I'm going to divide that 60 by the first number in my list, which is a 2. And I'm going to use short division. So 2 into 60 goes 3, no remainder, and 2 into 0 goes 0. So I get a 30. And I get to do what? Divide one more time. I'm going to make that a little bit larger and a little more space so it looks better. And I'm going to divide by 2 again. Short division. 2 into 3. Once. Leftovers. 1, 0. 2 into 10 is a 5. Now question, can I divide by 2 again? What's my rule? I don't want a remainder. So will 2 go into 15? Yes or no, and why?
No.
Okay, no is correct. Why?
Remainder.
Okay, why is there a remainder? And if you tell me just because, not enough. Even numbers can be divisible by 2, odds can't. This is odd, not even. Will 3 work?
Yes.
Why?
Because it's an odd number.
No. 17's odd, and 3 won't go into 17. I need a better rule. No, 15's not prime. Will 3 go into 15? What's my rule?
No remainder.
5 and 0?
So I haven't heard the right answer yet. What? No, if it ends in a 5, is no guarantee. 25 can't be divided by 3. I need a rule. I gave it to you earlier.
You add 5 and 1.
I add the digits. Very good. I add the 5 and the 1 and get what? 6. 3 will go into 6, so 3 will go into my number. Again, the rule. Add the digits. 1 plus 5 is 6. 3 goes into 6. 3 will go into 15. Okay. Now, it's sort of trivial that 5 will go into 5, but I'll finish it off. If I multiply these numbers together, I will get 60. So I'm saying that I have 2 times 2 times 3 times 5. And I have written what? A product of prime factors. That's what you're going to do when we talk about this tomorrow. We'll just work with bigger numbers. More exciting that way. But notice, there's no room to do your long division you're familiar with. We have to use short division, correct? Now you have to be careful in this process. So Debbie, I'm going to leave this one on the board. I'll just walk off camera, and I'm going to go way over to the other side with camera 2 once you get your cameras adjusted. And we're going to look at the mistakes we can make. Not that we want to make them, but to be aware of them so you don't make them. So for example, I'm going to give you a pretty straightforward division problem. We know it's going to have an answer without a remainder. Why? Why no remainder? I'm dividing by 2. The number 210 is even, so I'm not going to have a remainder. So 2 into 210 is what I'm doing. But remember, we do it this way. Now let me show you the mistake. First, I'm going to show you what the answer should be, and then we'll look at the mistake, because this happens too many times. 2 into 2 goes 1, correct? So I put my 2 down here, I subtract, I get a 0, and then I do what? Bring down the 1. Now what should you do at this point? Do you bring down the 0? Or what should you do first? Oh boy. I think I would have trapped all of you, it looks like. Because 2 won't go into 1, and if it won't, you put a 0 before you bring down the next digit. Now, 2 into 10? 5. I get 10, and I'm done. Now the mistake, I'll show you the mistake I see. I will have the 2 out here, and people will do what I heard you wanting to do. 2 into 2 goes once. You put the 2 here, you subtract, you bring down the 1, you say, that didn't work, I'll bring down a 0. And put a 5. Bogus. Because what's 2 times 15? 30, not 210. That's like, don't smoke here, don't do this. We got it? Any question there? Okay, I'm going to change my problem. I have a 0 sandwiched in with that 1 and a 2. 102 now into 1728. So the question, what do you do in problems like this? You can guess at the number, agreed? So I know I want to go into these 3 numbers, and 2 would be too big. 1 works. But how can I avoid that guessing? So my question is, how can I avoid the guessing that goes on in this first step? And by the way, this is what happens. Now before I go any further, how do I know, the question I'm asking, how do I know what the next number should be? Because I look at 102 and I want it into 708. How do I know? What? Okay, but what number do I put up here? I have to guess at that number, correct? What does it look like? Let's say I put a 7. Will it work? Well, over here in scratch paper, I do what? I take 102 and I multiply it by 7, and what do I get? 14. I get a 714, correct? Will that work? It's too big. So we drop down to what? We say 7 didn't work. I erase that. I go to the 6. So I then do what? I come over here and say I have 102 times 6. That's going to be a 612. Then I put my 612 here. I subtract. I will borrow for the moment rather than forcing you into the Austrian method. And I have a 96 for a remainder. Now the question, what in the devil do you do with that 96? Okay, I could put a decimal point here and add some zeros and keep going. We haven't talked about decimals. So what do you do if you haven't talked about decimals? You could say, I have 96 left over 102, and write my remainder as a fraction. But we haven't done fractions yet, so what do you do? R96, which sort of you feel badly about, but that's about all I could do at the moment. And we'll deal with this later. Now, how do you avoid this guessing? There's a low stress method. We talked about low stress addition. Remember we did subtotals? We started at the top, did subtotals as we came down, writing the subtotal each time. I'm going to use a low stress method here, and by the way, this takes too much time to do in practice. So I'd probably go get a calculator. But in reality, there is a low stress method. Here's what you have to do. You start with 1 times 102, and you get that answer. Then you take 2 times 102 and get 204. Then you take 3 times 102 and get 306. Then you take 4 times 102 and you get 408. You take 5 times 102 and you get 510. You take 6 times 102 and you get 612. You take 7 times 102 and you get 714. You take 8 times 102 and you get 816. You take 9 times 102 and you get 918. Okay, let's slide over a little bit on this now, Debbie, just to here. What do we call this list I've just done? We have a name for it. Okay, it's multiplication, but we call it multiples of 102. So I sometimes write this list as 102x, meaning I'm multiplying 102 by 1, then by 2, then by 3. Now remember my question? I wanted to know, as we slide back now, Debbie, right here, I needed to know what would work, correct? So I had that 708, I had the 102 out here. So as I look at this list, I'll just slide it, we're in good shape right there. I have 708. What's the largest number I can have on my list? The 612 is the largest one, right? The 714 is too big, and I know immediately that I'm going to need the 6. Now that's the low stress method. It just takes more time. And you may get stressed just because it takes more time. Okay? Any question in that? Okay. How would I have to check this answer? Now, this isn't as easy. I have to check this. So I'm going to put a check here. Check answer. That means I have to take 102, multiply it by 16, and when I get my answer, do what? Add 96 in. So if I'm going to check this, this is 612. Put an X here, a 2, a 0, and a 1. That means I'm going to have 1, 6, 3, 2. Can you drop that just a bit? Thank you. There we go. So I have 1, 6, 3, 2, and then what do I have to add on to that? The 96 that was left over. So I have 1, 6, 3, 2, adding to the 96. That's an 8, that's a 12, that's a 7, and I get my answer. So, question, how do you check your work? Multiplication. This just happens to be a pretty rotten one. And again, in all fairness, if I have long divisions and they're rotten numbers, I will drive to a store and buy a calculator if I don't have one. But for what we're going to do with prime factoring tomorrow, no calculators used. You have to be able to do the divisions. Now the question, this is sort of a rotten problem. How many rotten problems do you have to do to get good at it? Well, will you turn to page 49 in your book, please? And this brings up a question about the books. My understanding is that today the bookstore is supposed to get them in. Is that correct? The bookstore today will get them in? That'll be good. That'll be both the orange covered and the white covered book. If you don't have one, they should be in today. Is it page 49, 5D? Is that the last problem in the set? Is that correct? Okay, so this is page 49, 5D, and let's take this problem. Could somebody read that for me, please? What does the problem say? 355,416 divided by 502? That's not too far from the problem I just did, correct? Now you say, well, that's not what was read, but that's the same as what was read. Okay, so that means I have to do what? Put the 502 out here, and then put the 355,416 here. I leave the comma out, and my guess is you don't want to use short division here. Now, you might want to do what? The list of multiples of 502. That's going to be time consuming. Or, let's see the next process. You take the first digit here, it's a 5, and you try to take it into the 3, won't go. Will 5 go into the next, putting 2 together? The answer is yes. Now if I put the 7 up here, I'm going to want to put it not here, not here, not here, all the way over here. Because 502 wouldn't go into 3, 502 would not go into 35, 502 will not go into 355. So technically I can put goose eggs here. We don't usually put them. And then put the 7 here. Now that's an important process. Next, I have to do what? 7 times 502. So over here I have a little bit of a scratch pad, and I put a 7 here, and I have no guarantee that this answer will be smaller than this. If it turns out that this product is bigger, then I'll drop from 7 down to what? 6. The only way to avoid that is the low stress method. Well, what do I get here? 3514. Do you agree? 3514. Now, I'm not going to do short division here. I get a 0, I get a 4, correct? And your next step is to do what? Bring down the 1, drop the 1, write the 1, go for 1. Isn't this the trap? What's the trap? 502 will not go into 401. So I have to do what? I have to put in that 0 and bring down the 6. Now that is a trap you have to be careful of. Okay? Any questions? And you just have to pay your dues. And I could have given you a whole lot more problems, but there's not much I gain in it. So let's look again at the kind of problem I'm going to ask you to do tomorrow. Okay, so the number I have in mind, let's see. 65, 130, 260. I have in mind this number. Now before I did a 60, right? Now I have a 260. And what I want you to do with me is start with this number. And remember my primes are 2, 3, what?
5, 7.
5. Remember the store 7 what? The store you go to. 7, 11. Then, next prime number can't be divided by anything but 1. 13. 12 you can divide by 2, 4, 6. What about the next one? 16 I can divide by 2 and 4. 17. Next one. 19 is 21 primed. Divide by 3, divide by 7. Next one. 22 can be divided by 2. 23. Good. Next one. We'll stop at this one. 27 can be divided by 3 and 9. What? 29. We don't need to drop down. We'll just leave that the way it is, Debbie. Okay, 29 happens to be the last one under 30. So we have these primes. We usually don't need to go very far. By the time we hit 19, we've done enough. Now what am I going to do with my 260? I'm going to start it down here and divide by what? The first prime in my list. This is the process I did before. This is what we're going to do on tomorrow's lecture. And knowing what you're doing will save you time. Otherwise, just go through that way. Now, the homework, if you know what you're doing, probably get done in an hour tomorrow. Not tonight, but tomorrow's. If you don't, you may spend 3 to 4 hours on it. So you got to know when to fold them. That's an old Kenny Rogers classic. Okay, start with 2. Are we ready? Short division. 2 into 2? 1, no remainder. 2 into 6? 3, no remainder. 2 into 0? 0. I'm going to do a kind of an aside for a moment. I just said that 2 into 0 is 0. Why? These two numbers multiply together to give this, and that's acceptable. So it was okay to have 0 over 2. That is okay. Is this okay? Let's try it. Can you tell me any number, otherwise the number I want up here, anything here times 0 is going to give me what? 0. I'll never get a 2. So this is bogus. Can't be done. Make sure you see the difference between those two. Okay, back to my problem. Divide by 2 again. By the way, it ends in a 0, so I know 2 will work. And you do not jump around. Go in order. Will 2 go into 13? Yes, 6 times. What's left over? 1. So I have a 1, 0. 2 into 10? 5. Will 2 go into 65? Will 2 divide into 65 with no remainder? What's your rule? What's my rule? I need to know why 2 won't work. Adding up has to do with 3s, not 2. The last digit must be even if 2 will go into there. 5's not even. Okay, so I crossed the 2 out. I'm done with the 2. Will 3 work? Now I want my rule. What's my rule for 3s? Add them up. Fill it up. Add them up. Move them out. And then you're supposed to say rawhide. So, okay, so we have 6 and 5. What's 6 and 5? 11. Will 3 go into 11 without a remainder? No. Again, 6 and 5 is 11. 3 will not go into it evenly. I'm done with 3. Will 5 work? Why? Ends in a 5. 5 will work. And I get what? 13, which just happens to be a prime. So I'll divide by that 13. I get 1. I'm done. Notice the poetic. 1. I'm done. Not totally rhyming, but close. So what am I arguing? That 260 can be written as what? What's my argument? As 2 times 2 times 5 times 13. So I'm arguing I can do this. Every part of that product is prime. But we're not done. I want exponents. Now I'm done. 2 to the second, 5 to the first, 13 to the first. I'm done. Any question? Now you're going to do about 20 of these tomorrow. So you'll want to get ready for it. If it takes 10 minutes per problem, that's 200 minutes. That's 3 hours plus. Okay, and if you only take 5 a minute, that's an hour and a half plus. Page 47. Page 47. 30 problems, right? How many seconds? 30 if you're walking on water. 60 seconds if you're normal. If you take more than 60 seconds, practice, practice, practice. Then, page 48, 49, I want to see your work. No calculators, no work, no credit, and you'll redo it. If you do short division, make sure that there's enough work showing that I can see you did short division. A calculator is not short division. Review test, page 191. 191. That's due tomorrow, page 191. Any questions? If you need more room, you could do work in the back of it, but be neat and try to see if you can crowd it in the space I've given you.